We're going to talk about the phosphorus site index and the phosphorus management tools. We'll refer to those as our phosphorus risk tools. At this point, we're phasing out of one and into another, but as has been said several times today, if you have a farmer who has any fields that are FIV 150 or above, you need to run both. So first of all, why do we need these tools to begin with? Why are some soils high in phosphorus? Why is phosphorus a problem? When is the phosphorus risk required? And what aids are out there to help you calculate these tools? So understand the first three things, and we have some tools out there that will make the calculation of these others as easy as we possibly can. First of all, why are some soils excessive in P? Why are they above 100 FIV? Why are they above optimum? And there's a number of reasons. There may be some over-application of commercial fertilizer. And that was certainly the case 25 years ago when I started at this. There were people that farmed by their recipe, you know. And by that I mean their dad, their uncle, their everybody. If they were growing corn, they put on X amount of Y products. And it's just the way they operated. They had what I call a recipe. And it may have been different for corn than it was for tobacco and it was for soybeans, but they totally ignored soil tests. And they just farm by what I call a recipe. And in that case, you can certainly have over-application of P if you're getting the amount of nitrogen you need. Also, in some cases, there are actual recommendations for crops in the excessive range. And that's true of tobacco and several vegetables. So even if you're above an FIV of 100, there can be a recommendation for a few crops. But the primary reason really is using organic nutrient sources at what we call a nitrogen-based rate, using a manure or a compost or a food waste to supply all of the PAN your crop needs, often leads to high phosphorus soils. So why is phosphorus a problem? Well, it can lead to something that we talked about earlier yesterday, and that is eutrophication. Eutrophication is basically over-fertilization of water. Fresh waters tend to be phosphorus limited. Those blue-green algae Dr. Torr talked about, they're making all the nitrogen that's needed, but the system is limited by phosphorus. So think back to Liebig's spiral. Phosphorus is the low stage, all right? So if you add more phosphorus, you're going to stimulate the growth of the creatures that live in the water, the algae, the green guys, all right? You're going to get an algal bloom. Things are going to be shaded out, like any grasses that live in the water are going to be shaded out. When things crash and die, they're going to utilize oxygen in the decay process, and anything that can't move is going to suffocate, all right? So we're going to have anoxic conditions. A lot of fish actually have some very elaborate sensory organs that tell them when oxygen's getting low and they can move out of the low oxygen zone. But think of a crop like an oyster that's sessile, it doesn't move. Oxygen gets low and it's cooked. Well, not cooked, but it's dead, you know? So how does that phosphorus get off ag fields or lawns or landscapes and get into the water? Well, it can happen by a number of mechanisms. First of all, we have no naturally high phosphorus soils in Maryland. Okay, and that comes from the mouth of Dr. Martin Ravenhorst, who's been the soil morphologist here for decades. Okay, I asked him flat out, Marty, we have any naturally high P soils in the state? Because I'm running into farmers that believe that their soils are just high naturally, and he said emphatically, no. All right, if they're high in P, it's because somewhere along the line, either fertilizer or animal waste have been applied to that soil. All right, so how does it get off the field and anywhere else? Well, you can have erosion. Erosion is the loss of soil particles over the surface of the soil. You can also have runoff, the flowing of clear water with no particulate over a soil surface. And research done 20, 25 years ago showed that if you have an enriched soil up here, and even clear water runs off that field, it can have high enough levels of soluble phosphorus in the runoff water to cause problems if that water reaches a water body. All right? So both erosion and runoff are major problems. You can also have phosphorus moving down through the soil. Now, the old soil books, for those of you that took soils years ago, they probably said, oh, phosphorus doesn't move, don't worry about it. But the fact is, in a soil that has minimal phosphorus fixation capacity and where you've applied lots of phosphorus for a long time, in our poultry area, right? Sandy soils, decades and decades of poultry production and poultry application. You can actually saturate your soils, and then if you apply more phosphorus, it's going to move down, it's going to leach. And if you have ditch drains or tile drains, ditch drains on the shore, tile drains over here, you can short circuit that leaching to the groundwater and move it into your ditches. Right? So we have ways in our environment where phosphorus leaves the field and can get into water. So when is the phosphorus risk required? Anytime the FIVP, that is our way of talking about soil tests in Maryland, is 150 or greater. And as we looked on that graph yesterday, 150 is way out in the excessive range. It's not at a point where it should limit anybody's ability to grow the crop at the yield goal they want. So if it's FIV of 150 or greater and the farmer intends to add any P-bearing material, starter on his corn, manure, compost, whatever, a P risk is required. Farmer has fields above 150 and he's not going to apply any P, you go, thank you, buddy, let's go get a beer, all right? But if he's going to apply anything, you need to run the P risk. So again, kind of reinforce this. Agronomic applications of soil tests, 0 to 25, it's low, is probably limiting yield. Medium, might or might not, you might want to do something about it. Optimum, you're probably okay because our critical value was here, but you might want to apply something. But above 100 FIV, you're in the excessive range. There's no indication that there's any limitation on your plant production capacity at that soil test. So when the hullabaloo started after the fish kills in '97, and it was quite clear that we were going to have to do something about phosphorus, the decision was made to apply an agronomic soil test in an environmental situation. So looked at the data and said, well, okay, where do we run into trouble? Where should we draw the line? And there was actually one thesis or dissertation, I forget which degree that young woman was working on, and her data showed that above about 150, phosphorus started to be more mobile in the soil. You could measure it in a soluble phosphorus extract, and it was probably potentially labile in the environment. So the cutoff of 150 FIV was used as the best criteria we had, based on the science that existed at that time, to use an agronomic soil test for an environmental application. And it was done, even though there was a better test that would have been available, it wasn't one that was done routinely in soil test labs, and the decision was made at that time to use the agronomic test in an environmental mode, even though it wasn't specifically designed for that initially. So again, to talk about this, I want to reinforce the fact that if someone is limited by how much phosphorus they can apply at 150 after you run this tool, it should not have any impact on their yield, right? You're out here in the flat line part where applying more phosphorus isn't doing anything in terms of enhancing your yield. So there's two P-risk tools out. The phosphorus site index has been around for a number of years. We started going through versions of it, different test versions about 96 or 97. It's now being phased out, and the phosphorus management tool is gradually being phased in. For the farmers that have a really high average soil test level, the first phase-in year is 2018. And among the extension client base, we do have maybe 25 people statewide that fall into that category. All farmers, though, are going to phase into it on their fields that are above 150 FIV by the year 2022. So both tools look at a whole array of characteristics. All right. So what I tried to do here was list the different characteristics that are taken into account, and then look at whether the phosphorus site index requires it or the phosphorus management tool requires it. All right? So one thing you look at is erosion. How much soil are you losing from that field? And that's taken into account in both tools. How much runoff? What is the runoff potential in this field? Both tools use that. What is the leaching potential? That's something that's used in the phosphorus site index, but it's not used in the PMT. You might ask yourself, well, why? Is the leaching important? It is, but a study done with the phosphorus site index to look at what characteristics contributed to the pool found that there was some redundancy, and leaching potential didn't measure anything else that wasn't already taken into account somewhere else. So it's not in the phosphorus management tool. Subsurface drainage and distance to water, you're going to see them in both. Buffers, both. Priority of watershed, and this is where are you in the state and how vulnerable or polluted is your watershed already. Used to be there was a hierarchy, and some watersheds were scored more heavily because of condition of them. Well, now with the TMDL, the decision was made, look, the whole state's under a TMDL. Let's not say one watershed's better or worse than another, or deserves more protection than another. So that's dropped out of the new tool. Soil tests are used in both in different ways. There's actually two soil tests used in the PMT, this new phosphorus saturation ratio that we knew about back in the 90s but decided not to use at that time. And both tools look at phosphorus application rates and timing and method application. I spoke earlier about asking farmers this whole laundry list of questions and how sometimes they get annoyed. Why do you need to know all this stuff? You wouldn't believe what you have to know just to figure out what timing and method of application you're going to use. And they're not the same questions for both tools. Now, I want to emphasize that you may look at erosion in both tools, but don't think they're scored the same, because the way they were set up mathematically is very differently. The PSI was quite streamlined. The PMT was constructed in a much more complicated fashion. So they may both be there, but they're not treated the same way. One thing that's really important is knowing the dominant soils in your field, either the dominant map unit or the dominant soil type. So you're going to have to know how to use Web Soil Survey, how to define your area of interest, and how to get that soil information, because you're going to need a map of every field with the map unit summary for that field in your file for every field you're doing the phosphorus risk on. All right? Because there are things tied to your soil that you're going to need information you're going to need to get. Your soil erodibility is used in your erosion estimates, your drainage class, your permeability class, and your hydrologic soil group all come into those calculations one way or another. Now, go back to this. Some fields have a clear dominant soil map unit from one soil type. Others don't. And if there's more than one soil map unit of the same soil type, my opinion is that you should go with the major soil type in your field. Okay, so typically your dominant map unit is like the one with the greatest area. Your dominant soil type is the soil type with the greatest area. Sometimes you will run into cases, and this comes in Howard County a lot, Glenelg and Manor show up all over the place. In this case, this was a field I was working on with one of our new advisors, and it had Glenelg A was 30% of the field, and Glenelg B was 30% of the field, but Manor was 40% of the field. Well, it makes more sense to look at Glenelg because it's making up more of the field in Manor than it does to say, oh, this map unit's more than this, because these are very similar. You know the difference between A and B? You guys from the Soil Conservation District, you know this. What's the difference between an A soil and a B soil? Slope, okay? So your A soil has less of a slope than your B soil, but the features, the essential features of the soil is the same. So if you have soil map units that are the same soil type, my opinion is to add them together. So you go with, this is 60% Glenelg, and then I would use GGB, or the higher slope one, for all my soil properties, okay? Now, in my opinion, you need a copy of the soil map and the soil map unit in your file. It doesn't need to be in the plan, but it's backup for some information you showed and used someplace else. So it does belong in that client's file. Here's an example of a field from the shore. Now, you'll find this a lot of times. People will mush together stuff and you'll go, are you sure that's the same, same productivity area? Look at this field, okay? Here, 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 here. He claimed he farmed it as one unit, all right? And when you look at I know it's a little hard to see, when you look at the soil map units, it turns out that Corsica Mucky Loam is 60%. So that would clearly be the dominant map unit in that field. It's higher than anything else, and it's the only Corsica there. So I'm comfortable with saying, okay, Corsica Mucky Loam. Now we talked a little, this is a bit of a digression, but we talked yesterday about there being no cultivated organic soils in Maryland, and that's true. Most of the organic soils are near the water bodies, and some of them are even brackish. This is as close as we get to it. A mucky loam means this is very high in organic content. It has a mucky classifier, even though textural class, it's a loam. Okay, you also need a lot of information from your grower. Crop rotation, type and timing of all tillage operations, all nutrient sources with their timing and method of applications, whether or not they have buffers, how wide they are, and whether or not there's any water features close to that field. All right? If you're going to do plans or you're going to assess things in plans, you're going to want to know about our website. We have plan writing tools and a handbook section of our website. And Chapter 6 is all the things you need to know if you have to do a phosphorus risk assessment. We have a data collection information sheet here if you need to do a phosphorus site index. And I would suggest you use the collection sheets, both this one and the other ones we have, because they help you organize the information so that when you leave, whenever you're visiting with your farmer, when you're done talking with him, you have 95% of what you need and you don't have to find him and bug him and contact him again for other things. First thing you're going to need to do is measure erosion. Some of you have been around long enough that you probably were exposed to the universal soil loss equation. That was nice. We could do it by hand in class. I had my freshman soil people do it. Then NRCS evolved into something called Russell. Computers became more widely available, and this could be done on a desktop. Right? Then they went to Russell 2. This looked at things at a 2-week interval across the year, integrated stuff across the year. It was very nice. Russell 2 actually looks at stuff day by day. It is the most accurate tool, and until NRCS comes out with their new tool, and I understand they're going to come out with that soon, this is what we should be using to estimate erosion. It's not a piece of cake, fellas. Who's used Russell 2? Not a piece of cake, is it? No. But it's the best thing we have. Okay. Anyway, it looks at all these things. Now, Russell 2 looks at an interaction on a day-by-day basis, but essentially, remember what tool we're talking about for erosion. It looks at rainfall quantity and intensity. It looks at soil erodibility. It looks at slope length and gradient. It looks at what crop and residue management you have, and it looks at whether or not you have extra conservation practices like contour farming or terraces or something like that. So Russell was very simple. We had these nice lookup tables. You could do it in a class with students. Russell 2, you needed lookup tables or a computer. Russell 1, you needed a lookup table or a computer. Russell 2, you absolutely have to do with a computer. There's a lot of stuff behind the curtain that you never really know what it's doing. So we do have some things to help you with this. We have a standalone version of the phosphorus site index. It's downloadable for free on our website. If you go to our website and look at software, you'll find that. And it allows you, once you know the information, there's still all this information gathering, all right? But once you know the information and you've estimated your erosion, you can use this tool to get your phosphorus site index. One of the beauties of this is it has all the current soil map units data downloaded from NASAS and embedded in it. So once you choose your dominant soil map unit, all that stuff that's stored in NASAS basically gets popped into the calculation sheets for you. Right? Essentially, though, what it's going to look at is your site features, your transport pathways. That's all in something called Part A. It's set up Part A, Part B. And then your management practices, you know, when do you put stuff out, how much do you put out, and your source, what's your soil test, what stuff are you putting out. They're handled in 2 separate parts, Part A or Part B, and it comes up with a score that supposedly tells you whether you've got a critical source area or not, or how serious a critical source area you have. And once you're done with all the calculations, you're going to come up with one of 4 rating classes. If you get a 0 to 50, you're in a low class. It means there's a low potential for phosphorus movement, and you can still do nitrogen-based recommendations for organic nutrient sources. If you're 51 to 75, you're already in a medium class, and even now there's some restrictions. You can only do nitrogen-based planting 1 year and 3, and the other 2 years you can do P-based or P-soil test-based. If you're high, 76 to 100, there's a high potential for phosphorus to move from the site. So if these folks have these scores even now, they're restricted to phosphorus-based recommendations, removal or P-soil test. And if you're above 100, you're very high and you can't add any more phosphorus, even under the tool we have now, the phosphorus site index. So not many people have been completely restricted from applying phosphorus. There's a very limited number of fields statewide that fell into this category. And but for the first 5 or 6 years we had this tool, I was monitoring feedback from what folks in the counties were seeing in the extension offices to see, are we getting any very highs and when do they occur? All right, and it turns out it was very low probability, and when we did find them, there were outrageous things going on in that field. I remember one from St. Mary's County where the person had 28 tons per year erosion loss on a field. 28 tons per year. Conventional tillage, vegetable production, high soil P. It's like, should you be adding any more P on this site? Really? So, you know, I couldn't feel sorry for this person not being able to find more phosphorus. You get my drift? No, there was a reason for it. Another case was over on the Eastern Shore where the person had an FIV of, now listen to this, 150 puts you into this category, 1,250. Okay? Now, does that person need to apply any more phosphorus? And should they have gotten a high score? Again, I had a hard time feeling sorry for them. All right. Some people have fallen into this category where all they can apply is phosphorus removal, and a number of people fall into this category where they can only do, for example, a nitrogen-based rate of their poultry litter 1 year and 3, and then the other years they're probably restricted from applying any at all because the phosphorus removal rate may be lower than their limit of technology, and we run into that problem a lot. Being able to do a phosphorus removal is also dependent upon can you apply that low an amount. And oftentimes with poultry litter, you cannot. Depends upon the poultry litter analysis again. Okay, now the phosphorus management tool is set up very differently. It looks at management, source, and transport for each tool independently. So it addresses some of the criticism of the phosphorus site index, and that is that there were high loss fields out there we weren't capturing with that tool. And we know that at least in some cases that appeared to be true. And it was true because we were in assess averaging all the transports in Part A. So you could have a high of one transport path and a low of another, and it still only gave you a low or a medium. But in this case, each pathway is assessed independently. So if any one of them is out of sight, you're going to get an out of sight score, even though the others may be low. Right? So a very different paradigm. Still looks at the three pathways, runoff, subsurface drainage, and erosion or particulate, but it looks at the transport, management, and source separately. Okay? There's also a different interpretation. Instead of 4 categories, there are 3. All right? 0 to 50 is low. The P applications can't exceed the P removal over a 3-year period. And for any one crop, you can't exceed the nitrogen rec anyway. Medium is 51 to 100, means you can do no more than the P removal for the year of application. And if you're a high, you can't apply any P at all. So the tools look at different factors. They look at them different ways, even though they may call it the same thing. They look at the transport pathways differently. Instead of mushing it together, they look at them separately, and they have different interpretive tables. Now, you can do the phosphorus size management one of 2 ways. If you're using our Newman software to get your recommendations, the phosphorus management tool is a component of that. So if you've done all your stuff for your recommendations, your fields, your crops, your manure, whatever, and you go over to the PMT module of this software, it carries over all that stuff you've already done. So it knows what field, it knows what soil test, it knows what crop, it knows what manure, it knows what organic P applications. So if you're using this software, the PMT is built into it. If you're not using that software and you have other recommendation software that's consistent with Maryland regulations, you can do the PMT using the standalone version, right? You might want to play around with these if you have morbid curiosity like I do, okay? Some fields you work with, the county you're in, look at some scenarios. They're quite easy to use. Okay, so let's look at this. Starting in June 15, the regulations changed to say that there could be no P applications if the FID is over 500. If it's over 500, you can't add any more right now. And until 2020, and then it depends upon your phosphorus management tool. They also specified that everybody who was doing plans needed to look at the phosphorus site index and the phosphorus management tool for the fields they were developing plans for. We in Extension have been doing that since 2013 because we thought it was important for farmers to know if they were going to be slammed or negatively impacted by the PMT phasing in. But at this point, everybody, private sectors, folks need to do it too. And then there's a gradual phase out of the PSI and a gradual phase into the PMT with some people that have the highest. If their soil tests and their high P fields are greater than 450, they have to start using PMT in transition 1 this year. Okay, so that was the quick and dirty of this. You know, why? You've got tools out there to help you. We've got all kinds of fact sheets there and assessments and whatever so that you can learn to do these. And if you run into a situation where you are having difficulty using them, let Melissa or I or Paul know. We'll help you out.